Am I audible?
Yes, sir.
Okay. So let's start. Hydrogen. This is the last chapter in your midterm syllabus, no?
Yes, sir.
Okay.
सर केमिकल चेंजेस एंड रिएक्शंस भी है।
अच्छा, केमिकल चेंजेस एंड रिएक्शन भी है, ठीक है, हो जाएगा सितंबर ना।
यस सर।
डोंट वरी, इट विल बी कंप्लीटेड। पे काम करना, केमिकल चेंजेस एंड रिएक्शन का जो इंडेक्स है ना तुम लोग के बुक में, वो इंडेक्स ही फिर हम तो व्हाट्सएप कर देना, मतलब ग्रुप में पर व्हाट्सएप कर देना आज, ठीक है?
ओके सर।
तो देखो हाइड्रोजन जो है, तो हम लोग पीरियोडिक टेबल पढ़ चुके हैं। तो पीरियोडिक टेबल में हमको क्या पता चला कि हाइड्रोजन कहाँ पर प्लेस्ड है, इन फर्स्ट पीरियड एंड इन फर्स्ट ग्रुप। तो पहले हम लोग देखेंगे हाइड्रोजन का सिंबल क्या होता है। हाइड्रोजन का सिंबल होता है 1 H। इसका जो एटॉमिक नंबर है, जो हम लोग स्ट्रक्चर ऑफ एटम में पढ़ चुके हैं, एटॉमिक नंबर मीन्स नंबर ऑफ प्रोटॉन्स और नंबर ऑफ इलेक्ट्रॉन्स, ठीक है? दैट एटॉमिक नंबर इज 1। एटॉमिक मास इज ऑल्सो 1, ठीक है? मॉलिक्यूलर फार्मूला क्या होगा? दिस इज सिंबलिक फार्मूला ऑफ एटम। सो मॉलिक्यूलर फार्मूला बिकम्स H2, ओके? हाइड्रोजन फॉर्म्स H2। सो मॉलिक्यूलर मास कितना होगा? 1 + 1 दैट इज 2, ओके? एंड पोजीशन फर्स्ट इन पीरियड and first in group, that is group 1A, according to old or modern period table। so group 1 first in period first in group, ये उसका पोजीशन हुआ। ये मॉलिक्यूलर फार्मूला, ये मॉलिक्यूलर मास, दिस इज द सिंबलिक फार्मूला ऑफ एटम, दिस इज एटॉमिक नंबर, दिस इज एटॉमिक मास। क्लियर? एनी डाउट?
नो सर।
ओके, so next, hydrogen, the position of hydrogen is very much debatable, okay? Because hydrogen shows some chemical properties similar with group 1 element and also group 17 element in modern periodic table, or 7A in the old periodic table, okay? So hydrogen resembles chemical properties both with group 1 or 1A and group 17 or 7A. So we have to next study that what are those similar properties between hydrogen and group 1 elements and between hydrogen and group 17 elements, okay? So next topic is similarities between hydrogen and group 1 element is known as which kind of metal? Group 1 elements are known as what did I told? Group 1 elements are known as fast बताओ। Group 1 elements are known as alkali metals, ओके? इससे याद करना है, ग्रुप 1 alkali metals, ग्रुप 2 alkaline earth metals। जो नेम्स लिखा है तो वो नेम्स तो याद करो। तो देखो फर्स्ट प्रॉपर्टी जो है दैट इज इलेक्ट्रॉनिक कॉन्फ़िगरेशन, ओके? इलेक्ट्रॉनिक कॉन्फ़िगरेशन, इलेक्ट्रॉनिक कॉन्फ़िगरेशन मीन्स देखो अगर हम लोग सपोज कोई भी एक ग्रुप 1 एलिमेंट्स ले ले, ठीक है। यार हाइड्रोजन और इसके नीचे था मेरा लिथियम, सोडियम, पोटेशियम, ग्रुप 1 एलिमेंट। हाइड्रोजन का कॉन्फ़िगरेशन क्या था? 1। लिथियम का 2,1। सोडियम का 2,8,1। पोटेशियम का 2,8,8,1. Okay, so if we look into it, so we can see that there is only one electron present in the outermost shell or outermost orbit. Okay, only one electron present in outermost shell for hydrogen and also the group 1 elements. This is the similarity in electronic configuration, that they have only one electron in their outermost shell. Okay, in their outermost shell. हाइड्रोजन में भी एक इलेक्ट्रॉन है, अदर्स elements of group 1 also contain one electron in outermost shell. This is the similarity. Next similarity is valence electron. So look, from here we can say that these electrons are valence electron because the last shell present is known as valence shell, and the electrons present in valence shell is known as valence electron. Okay, so all elements have only one electron in outermost shell. So their valence shell contain only one electron. So valence electron will be 1, as all the elements having one electron in their valence shell. So number of valence electron is 1. Third, their valency. So from structure of atom we have studied that valency means the number of capacity. Okay? Here valency also told that number of electrons donated by the outermost shell or accepted electron in outermost shell. Okay, combining capacity is valency. So they have only one electron in outermost shell, so their combining capacity is 1. So their valency is also 1. All the alkali metals and hydrogen having valency +1. Okay, next, ion formation. So look at here, these elements, by donating this electron, it will form ion. They can donate only one electron. Okay, because they have only one electron in outermost shell. So after the donating of one electron, suppose lithium donates electron, it form lithium plus. Sodium donates one electron and it will form Na plus. So similarly, if hydrogen donates electron, it will form H plus. Okay, so basically by the donation of valence electron, they form mono positive charged ion. plus sign A, Fe plus sign A. This is called monopositive. Only one positive charge. So they form monopositive charged ion by losing of one electron. Okay. By losing of one electron. Next. Next is burning. Okay. Burning means reaction with air, means oxygen. So when they react with, they form oxides of element when burns. Okay, like hydrogen, if reaction with oxygen, it will form hydrogen oxide, that is called water. Similarly, if lithium burns with oxygen, it will form lithium oxide, that is Li2O. Okay, but if sodium reacts with oxygen, it forms sodium peroxide, and potassium burns with oxygen, it forms potassium superoxide, CO2. Okay, but they form different oxide. They form oxide. Okay, one more similarity we can say, that is reducing power. Reducing power means reduces others and oxidizes itself. So from ion formation, we can say that lithium donated electron, hydrogen donates electron. So by the donation of electron, hydrogen and group 1 metals gets oxidized. So itself they get oxidized, so they have in the reducing character. Okay. So we can say that both the hydrogen and group 1 elements behave like reducing agents. Both the hydrogen and group 1 elements behave like reducing agent due to the donation of electron. Due to the donation of electron. The element which donates electron is reducing agent, which reduces others and itself get oxidized. Here we can take an example where not electron transfer, but by the others reaction we can reducing. Like suppose CuO, copper oxide, reacts with hydrogen, it forms Cu and H2O. Here copper oxide to copper. Copper is being reduced here. Okay, and hydrogen is getting oxidized. Hydrogen is getting oxidized. रिडक्शन और ऑक्सीडेशन समझ में आता है?
Yes, sir.
Oxygen is attached with hydrogen, so it is oxidized, and copper releases oxygen, so it is reduced. Okay, so here it is based on hydrogen. Similarly, if we take copper oxide and sodium, then also it will form copper and Na2O. So here copper reduced and sodium oxidized. So these are the basically similarities of group 1 elements and hydrogen. Okay. Next we will see the similarities between hydrogen and halogens. Okay. Note down हो दिया पूरा. Done.
Yes, sir.
Yes, sir.
Okay. The next similarities of hydrogen and halogen. Heading करो जल्दी से. Similarities between hydrogen and halogen. So here also the first point of similarities is electronic configuration. So we have to look at that electronic configuration. Hydrogen shows similar electronic configuration with group 1 element. So how it is possible to show that similar electronic configuration of hydrogen and halogen, right? Because if we take hydrogen, so its configuration is 1, and if we take any halogen like suppose chlorine, its configuration is 2, 7, Cl 2, 8, 7. So there is no similarities in electronic configuration, no? But they show electronic configuration similar, like how that if hydrogen will accept one electron, it becomes its outermost configuration becomes 2. That is the nearest noble gas configuration. Okay. If it will accept one electron, so it becomes nearest noble gas configuration, that is helium. Okay. If it will accept one electron, so it becomes 2, 8. That is nearest noble gas configuration neon. If it will accept one electron, so it will be argon. On the basis of that theme, hydrogen and group 17 elements show similar electronic configuration. Okay, that means that hydrogen and halogens have been one electron short to the nearest noble gas configuration. But here was one electron in valence shell. They have been one electron in valence shell. This is the similarity. And here is the similarity on basis that how many electrons it can accept in its outermost shell. Okay. So the similarities is they have only one electron short to the nearest noble gas configuration. Got it? So we can say valency is same because valency means number of electron donated or number of electron accepted. So they can accept one electron. So they have been the same valency. They have been similar valency, that is -1. By accepting of electron, that's why -1. By donating of electron, that's why there was +1. Okay. Now tell me, if it will accept electron, So it will produce ion which will be positively charged or negatively charged. Tell me, if hydrogen and these elements will accept one electron, so they will form positively charged ion or negatively charged ion. Response, do response first. If they will accept electrons, so they will produce negatively charged ion. By donating of electron, they will produce positively charged ion, and by accepting of electron, they are producing negatively charged ion. And one negative, that means mononegative ion. Okay, so we can say that both show a tendency to form mononegative charged ions. Mononegative charged ions by accepting of one electron. Okay. Next, electronegative character. Both are accepting electrons, so they can, so we can say that they are having electronegative character. By the accepting of electron, we can say that they are having electronegative character. Okay. Next, atomicity. Atomicity means number of atoms present in one molecule. Okay. This means number of atoms present in molecule. How many number of atoms contained in molecule? So we can say that if hydrogen combines, so it forms H2. If fluorine combines, it forms F2. If Cl combines, it forms Cl2. Okay. So both exist in the form of diatomic molecules, because two atoms present, so diatomic. One atom, monoatomic. Three atoms, triatomic. Okay. So both the hydrogen and halogen having diatomic molecule. Having a halogens exist, halogens exist as a diatomic molecule. Okay. So these are the similarities between hydrogen and halogen. Now we will see that some different Some differences between halogens and group 1 and hmm, some dissimilarities between hydrogen and group 1 and 17 elements. Okay. Dissimilarities between hydrogen and group 1 and group 17 elements. So look at here first point. Hydrogen having the configuration 1, sodium having configuration 281, chlorine having configuration 287. So we can say that hydrogen having only one cell, but group 1 elements and group 17 elements having more than one cell. Okay, this is the dissimilarities, that hydrogen having only one valence cell, not valence cell, means last cell, only one cell in its electronic configuration, but group 1 and 17 elements contain two or more than two cells. Okay. Next dissimilarities with group 1 elements. Okay, that hydrogen is non-metals, but group 1 elements are non-metals or metals. Group 1 elements metal or non-metal?
So metals.
Metals. So group 1 elements are alkali metals, we know. So this is the basically dissimilarities between group 1 and hydrogen. Next we can say oxides of hydrogen क्या फॉर्म हुआ था, that is H2O. It is neutral. Okay, whereas oxides of group 1 elements are basic in nature and group 17 elements are acidic in nature. Okay, they are acidic in nature. We have to remember these points only. Okay, so on the basis of these total things, similarities, dissimilarities, hydrogen is kept on the separate position in periodic table, that is first in period and first in group, because periodic table is starting on the basis of atomic number, and hydrogen having atomic number 1, so it is placed in the first in period and first in group. However, on the basis of atomic number, hydrogen is placed in the separate hydrogen is placed at the separate position in the periodic table. That is first in period and first in group. Note it down first and tell me. Done?
Yes, sir.
Okay. So after this total, we can say that discoverer of who is the discoverer of hydrogen? It is the question. So discovery of hydrogen, the credit goes to Henry 70s. Okay, Henry 70s. Okay, is the discoverer of hydrogen. He first discovered hydrogen by the reaction between metals and some dilute acids. Okay. However, in later, Robert Boyle had prepared the gas, okay, by others elementary nature, and Lavoisier further it is called hydrogen. Okay, and further Lavoisier called it as hydrogen. Okay, now we will see that maximum hydrogen produces in which state? Liquid, solid, or gas? Hydrogen found in generally gaseous state. Okay, sometimes it is combined state like water, glucose, etc. It is formed. You should remember this. So now we will see the reactions by which hydrogen can be prepared. Okay, so preparation of hydrogen. Okay, preparation of hydrogen. So look at here, by the reaction with metal and water, hydrogen produces. Okay, by the reaction between metal and water. Like if we take sodium in water, so we know that it exothermic reaction and produces sodium hydroxide and hydrogen gas. Okay, this reaction is very much exothermic, violent. This reaction is very much exothermic. Okay, that means lots of heat liberated. Okay, so basically when we placed sodium in water, sodium hydroxide and hydrogen form. Hydrogen is gaseous substance. It will liberate from the mixture, and due to exothermic reaction, lot of heat produces. With that heat, this hydrogen gas starts to burn. That's why we are seeing that there is there catches fire on water. Basically, that fire is not on water. The hydrogen that's present over water starts to burn. Okay, so generally we did not take this reaction for the preparation of hydrogen. Okay, just because of its violent reaction. We can prepare by taking potassium. Potassium is the less violent than sodium. Okay, like potassium, यहाँ पर हम लोग क्वेश्चन पूछ सकते हैं. Here one question asks that why water catches fire when reacts with sodium. So we can say that due to exothermic reaction, lot of heat produces, which burns the hydrogen gas over water. Okay, so to avoid this exothermic or this violently, we can take potassium. Potassium plus water, it produces KOH plus H2. This is less violent and comparatively less violent. Okay, तीसरे रेस्पेक्ट में हाइड्रोजन के रेस्पेक्ट में, but this is not preferable because of highly exothermic and highly violent. Potassium, sodium, both are violent. Okay, so potassium is more reactive than sodium. Potassium shows the more violent. Okay, compared to sodium. But both of these violent, so we are going to avoid this reaction. Potassium is also violent reaction. Okay, compared to sodium. Sodium is less reactive. No, I mean lithium, potassium, sodium. Huh? So this is the less violent. This is the more violent. This is also exothermic and violent. Okay, potassium shows more violent character than sodium, so we are going to avoid this reaction. But if we take, so this will form hydrogen form in here. Similarly, this is first, this is second. If we take another metal like group 2 metal, that is calcium, so metal reacts with water, it forms metal hydroxide and hydrogen. Okay, so it forms metal hydroxide, that is calcium hydroxide and hydrogen. If we take magnesium, so magnesium reacts with water to form magnesium hydroxide and hydrogen. Okay. Now, both of these are violent reactions, so we are avoiding this. Calcium is very much costly, that's why we are avoiding this. And magnesium, this reaction is slow. Here, the consequences is calcium is costly, so we cannot prepare generally. And this reaction is slow. We need some amount of heat to carry out the reaction. Okay, any doubt?
No, sir.
Okay, so by the reaction between metal and water, metal hydroxide and hydrogen gas formed. Sodium, potassium, both are exothermic, both are very violent. Potassium is more violent compared to sodium, so we are avoiding these two reactions. Calcium also forms hydrogen, but calcium is costly, so we are avoiding this reaction. Magnesium forms hydrogen, but magnesium, the reaction between magnesium and water is slow. It needs some heat. It needs heat to faster the reaction. Okay. Now this is the metal and water. Sometimes by the reaction between metal and steam also produces hydrogen. Okay, like magnesium, I told that magnesium needs some heat. So if magnesium H2O, ठीक है, बेहतर में steam, so it forms magnesium oxide and hydrogen. When reaction with steam, metal reaction with steam, it forms oxide, not hydroxide. Metal reacts with normal water, forms hydroxide and hydrogen. Metal reacts with steam, forms oxide and hydrogen. Okay. Suppose we are taking aluminum. So aluminum plus steam, it gives aluminum oxide. And we know that this layer is known as protective layer. Okay, it will decompose on the aluminum and it stops the reaction. After some time, we rub this aluminum with sandpaper, then this layer will be removed out, then other reaction will be carried out. Okay, have you seen the videos posted in the My School app or YouTube channel for reaction between metals, acid, metal, water? Anyone? Have you seen those videos?
Yes, sir.
Okay, so you can see that the reactions of metal and acids to produce hydrogens. Okay, we are going to on the next part. Similarly, tell me if jeans reacts with steam. So what will be the product when jeans reacts with zinc oxide or zinc hydroxide? When jeans reacts with steam, tell me, jeans reacts with steam. The product is oxide or hydroxide? First
An oxide.
oxide. So what is the formula? This is zinc oxide. Okay. So basically, normal normal water gives hydroxide and steam gives oxide and hydrogen. Okay. Next, those reactions which are performed in activity, those are placed in our My School group. Metals and acid. Okay. Metals and acid. These are the first points. Okay. This is first point A. This is first point. Second point B. Now C. That by the reaction between metal and dilute acid. Okay, by the reaction between metal and dilute acid. So we have already seen in videos that suppose any metal zinc reacts with dilute acid, that is dilute HCl, it produces a salt, that is ZnCl2, and hydrogen gas. Okay, if we will take magnesium plus dilute HCl, it forms MgCl2 plus H2. Suppose we are taking zinc plus dilute H2SO4, so it produces zinc SO4 salt, zinc sulfate, and hydrogen gas. Okay, so when these are upward signs, so when metal reacts with dilute acid, it produces hydrogen. But here remember one thing, that only highly reactive metals or moderately reactive metals are able to produce hydrogen. Okay, But the highly reactive metals, when react with uh, acid, it is more exothermic, so it can be burnt. And less reactive metal cannot be replaced hydrogen. Okay, because it is the less reactive. Okay, like have you remembered metal activity series? Have you remembered metal activity series?
Yes, sir.
Okay, so we can say that look at here: lithium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold. This is the metal activity series. Okay, here we have read that lithium, potassium, sodium, okay, those are most reactive metals. So this will be explosive. Okay, that's why we cannot use. But they can replaces hydrogen from their acid. Okay, this is one kind of displacement reaction where more reactive element displaces less reactive element. Okay, generally we are taking moderately reactive elements. Okay, not violently like this one moderately. This is replaces but not explosive. Gently, but they do not displace hydrogen. These are elements below the hydrogen. Elements below the hydrogen are less reactive one. They do not replace hydrogen from acid. Okay. Most reactive metals and moderately reactive metals can displaces hydrogen from acid, but less reactive ones are not. Clear? Any doubt?
No, sir.
Okay. Last process that metals reacts with some base. Okay. When metals reacts with some base to form hydrogen. By the reaction between metals and alkali. Look at here. Suppose we are taking uh, zinc reacts with alkali, that is NaOH. It forms Na2ZnO2 sodium zinc plus hydrogen gas liberates. If we take aluminum reacts with alkali, aqueous alkali, that's why H2O. It forms sodium metaaluminate, okay, NaAlO2 plus hydrogen. If there is no water, only aluminum and sodium hydroxide, it forms sodium aluminate, that is Na3AlO3 plus H2. This is sodium metaaluminate. Okay, sodium metaaluminate, and this is sodium aluminate. Sodium metaaluminate, and this is sodium aluminate. So when metaaluminate forms, when water present, and when aluminate forms, when only NaOH present. Like here, GGSIPU. When GGSIPU forms, then only NaOH. Okay. So look at here. Zinc aluminum reacts with base to gives hydrogen. Zinc aluminum reacts with acid to form hydrogen. So these metals are called amphoteric. Okay. These metals are called amphoteric and oxides are called amphoteric oxides. Those metals which are reacting with acid and base both are called amphoteric and their oxides are amphoteric oxides. So examples are tin, lead, aluminum, zinc. Okay, those are amphoteric metals and their oxides are amphoteric oxides. No, write down. Hmm. Done.
Yes, sir.
So what is amphoteric metals or amphoteric oxides? Those metals which react with both acid and base are amphoteric metals and their oxides are amphoteric oxides. Aluminium, zinc, tin, lead, etc. Okay. So hydrogen can be prepared by the reaction of metals and normal water. Where sodium potassiums are mostly active, they forms explosion. That's why we are going to avoid them. Calcium also, magnesium also produces hydroxide and water, hydrogen. When reaction with steam, metal forms oxide and hydrogen. And dilute acid then forms salts and hydrogen. And some metals reacts with base to give hydrogen. Okay. Any doubt till now? Having any doubt till now? Tell me fast because time is very short. We have to
No,
complete.
sir.
Okay. So next, laboratory preparation of hydrogen. We have to see that how hydrogen is prepared in laboratory. Okay. I'm going to only give you the knowledge of how laboratory preparation is done. Procedure you can read from your books. Okay. What happened? There is one kind of we have to take bottom flask. Okay. Bottom flask means like this. Okay, flask looking like this. This is called bottom flask. Okay. In this bottom flask, with the airtight cork, we will pour a thistle funnel. Okay, we will take a thistle funnel. This is called thistle funnel, and this is flat bottom flask. This is bottom flask. Flat, the bottom side of flat, so it is shaped smoothly. Okay. Here in this thistle funnel, one uh, cork. This is cork. Okay, and here is one knob is present. Now in this bottom flask, we will take some pieces of zinc. These are the pieces of zinc. Okay, and these zinc are not in the solid form. This is dust form or granulated. Granulated means very smaller pieces. Okay, so it must be granulated or dust zinc. Okay, not like this kind of solid. No, very small or dust form zinc. That is called granulated zinc. Okay, granulated means very small or dust. हम लोग dust कर सकते हैं. Now from this thistle funnel, we are going to add dilute HCl or dilute H2SO4, whichever you have present in your hand. Okay. So what we'll see, dilute H2SO4 or dilute HCl will come here. Okay, and it will be covered up over here. Okay, so as soon as dilute HCl or H2SO4, that means dilute acid, makes contact with granulated zinc, the reaction will start between acid and zinc. The reaction will start and the hydrogen formation is start. Okay, so see, here is no other way to escape the hydrogen which will be produced. So we will add one more. This is not यहाँ तक रहेगा, ठीक है ये. This will be up to here, up to here. There is some upper position compared to the acid level, some upper position. A long tube connected in a delivery tube through which hydrogen gas can be liberated out, and this tube will be placed to the water. Okay, this is water. This is water, and in water we have to take one bottle placed okay where water is present. Through this hydrogen is supplied. Now the hydrogen which is produced by the reaction between zinc and acid will be supplied through this pipe delivery tube, which will be collected in this jar. Okay, in this jar by the downward displacement of water. Okay, downward displacement of water. So what is the reaction? No, zinc plus dilute HCl, it produces zinc Cl2 and hydrogen gas, or if it is dilute H2SO4, then it produces zinc sulfate and dilute hydrogen gas. Okay, so what is the procedure? Now, at first we will take granulated zinc in bottom flask and we will add some acid, dilute acid from thistle funnel. Whenever acid and granulated zinc come closer to each other, contact with each other, the reaction starts and hydrogen gas starts to form, and it will be liberated and it will be passed through this delivery tube over the pipe and a jar which is kept over the water. Okay, and hydrogen is collected by the downward displacement of water. Okay, if this reaction is slow, hydrogen preparation is slow, then we will add some amount of concentrated acid to faster the reaction. Okay. Now from here the question is how hydrogen is being collected. So remember, collection of hydrogen, how it is collected? It is collected by downward displacement of water. Okay, downward displacement of water. वाटर तो हटाएगा, हाइड्रोजन प्लेस होगा. Why? Because hydrogen is almost insoluble in water. वो वाटर में soluble नहीं होता है. So we can collect it by downward displacement. But hydrogen, when contact with air, it there's explosion. Okay, hydrogen makes explosive mixture with air. That's why we cannot collect hydrogen by the downward displacement of air. We will collect hydrogen by the downward displacement of water, because with water it does not, the air does not soluble, but when it will be collected by the downward displacement of air, it will make an explosion. Okay, so by this process in laboratory, hydrogen is being prepared. In our next class, we will discuss about the impurities present in this preparation and the removing processes of those impurities, and what are the some precautions we should take during the preparation of hydrogen in laboratory. That all the topics will be covered in your next class. In next class, the chapter will be completed. Okay, till now, if you have any doubts, then tell me.
No, sir, no doubts.
Okay. Okay, so see you in the next class with rest of the portions, and the chapter will be completed. And Kirti Deep or who one having chemical changes and physical changes?
So I am having Kriti.
Kirti Deep. So please send me the index of that chapter. Okay.
Okay, sir.
Okay. Okay. So see you in the next class. नोट डाउन हो गया? नोट डाउन कर लिए?
Yes, sir.
ओके, तो प्रोसीड्यूर समझ में आया ना? प्रोसीड्यूर एक बार रीड कर लेना बुक से, कुछ है नहीं, सिर्फ ये पास करना है, तो वही लिखा हुआ होगा. ठीक है. ओके.